Hi, Dr. Lane. This is Cara. I'm reassessing my circular motion standard, and the problem I'm attempting is that a car is going around an unbanked curve at 11 meters per second. If the radius of the curvature of the path is 25 meters and the coefficient of static friction between the rubber and the road is 0.7, does the car skid as it goes around the curve? And what is a safe speed with wet road conditions where the coefficient equals 0.5. So in my work here, first look at my free body diagram. We have the car working with the only force in the horizontal would be the friction force, and then we have in the y direction the normal force and gravity. So first I'm going to find the radial acceleration for 11 meters per second. So I take acceleration equals v squared over r. So I have my acceleration of 11 meters per second squared over 25 meters. So I get 4.8 meters over second squared. So then I take my F net in the x direction would be max, because the only force we have would be the friction. So m times v squared over r. F net is just equal to the friction force, so friction force is equal to m v squared over r, according to this. Only friction force in that direction, because that's the direction we're accelerating. In the y direction we have n minus mg, because n would be positive, mg is negative, so that could also be written as n equals mg. And then we also have this equation here. This is one of the, I guess, the known equations that we have, that the friction force has to be less than or equal to mu s n for static friction. So we can substitute in what we know, that friction force is equal to m v squared over r, and then since n is equal to mg, we can substitute that on this side, and that gives us m v squared over r is less than or equal to mu s mg. And then our masses cancel because we have one on both sides, which leaves us with v squared over r less than or equal to mu s g. So the car can't go faster than mu s g, so the speed is limited to this equation. Velocity is less than or equal to the square root of mu s g r. So then I can substitute in all my values into that. 0.7 times 9.8 meters over second squared times 25 meters, take the square root of that, and that'll give me velocity must be less than or equal to 13 meters per second to not skid. And since 11 meters per second is less than 13, the car won't skid. So now I want to look at the same road, but it's wet, so the coefficient is going to change to 0.5. So we'll take that same equation, v is equal to the square root of mu s g r, and this time we'll just use 0.5 instead of 0.7. So we're looking for the max velocity that you can have in a wet road condition. So this is equal to the max velocity. So 0.5 times 9.8 meters over second squared times 25 meters, take the square root of that, get 11 meters per second, which was the posted speed limit, I think, in the question. And then that's the fastest a car can take the curve in wet conditions without skidding. Okay, thank you.